Assalamu alaikum wa rahmatullahi wa barakatuhu. Welcome to Wisdom International School's digital classroom for mathematics. So children, we have come to part 5 of this lesson. Already we have completed 3 exercises. So now we will continue with this chapter. So now there is a new topic. We are going to find the volume of 3 solid figures in this exercise. That is a cube, cuboid and cylinder. Okay. So we have already learned these formulas, but still I have written these formulas. See, a cuboid is a figure which has a length, breadth and a width, height, that is right, length, breadth and a height. So it's a rectangular box kind of a thing, right? So here this is length, this dimension is length, this is the width, or sometimes it's called as breadth or width, okay, and this is the height. Now when you're given a cuboidal box and they ask you to find the volume of the box, you will just multiply all these 3 dimensions, length, breadth and height, LBH. Okay, similarly a cube is a figure which has length, breadth and height. All 3 are same for cube. Okay, L, B and H are all equal to L itself, the same size. So but the formula is going to be the same, L into B into H, but here you are going to write L into L into L. Okay, so that's going to be L cube. Okay, this is because all the 3 dimensions are same. Okay, now if they ask you to find the volume of a cylinder, see, you have all come across a cylinder, right? So this is how a cylinder looks like, right? And a volume of a cylinder is given by this formula, pi r square h. Okay, r is the radius of the cylinder. See the circular base, it is like a circle, right? The base is like a circle, the top and the bottom. So it has a radius. So that radius is your r and the height of the cylinder is your h. The value of pi is 22 by 7 or 3.14. Now if it is given specifically to use 3.14, in question itself they will give you what to use. Okay, if they give that you have to use 3.14, then you use it. Okay, if they have not given anything, then you can use either, but 22 by 7 works better. Okay, so there is nothing like, there is no hard and fast rule that you have to stick to a particular value. You just solve it, you just use it according to the question, according to what is easy to solve. Okay, so now you will come across these 2 words in your exercise. Okay, that is volume and capacity. Okay, so volume and capacity, like if I ask you what's volume, it refers to the amount of space occupied by an object. So if there is an object, this is when I talk about volume, it's the 3-dimensional figure, it's a solid figure, not a area, not like a rectangle or a square. It's a solid figure like a cube, cuboid, a sphere, a cylinder, a cone, etc. Okay, so now volume is the space which is occupied by this figure. Okay, a particular solid object, whatever space it covers is what is your volume. So capacity refers to the quantity that a container holds. Like capacity is like if I give you a box and if I ask you how much of water can you fill in that particular box. Okay, so then that is actually called as the capacity, like how much of water it holds. Okay, so it basically both of them mean the same. Like mathematically when you solve it, volume and capacity are going to be used by the same formula. Using the same formula you get both. Okay, so it just depending upon the sentence, depending upon the usage, we use the word volume or capacity. Okay, so now let's go to the exercise directly. See, given a cylindrical tank, in which situation will you find surface area and in which situation volume? See, you know now what volume is, right? That is the space covered in between, inside the object. Okay, and surface area is what we have learned already. Surface area is the area of all the sides, right? All the sides, like all the walls. Like if I say that you're sitting in a room is in the shape of a cuboidal room, right? It's like a box, isn't it? So all the 4 walls area and volume of the area, all the 4 walls area and the area of the floor and the area of the roof, all 6 sides added together gives you the total surface area, or simply we call them as surface area also. Okay, so now we know the difference between surface area and volume, right? Surface area is the area covered by the walls and the roof and the floor. Okay, and volume is the air, the area the space which is there inside the room. Okay, so that's like your volume. So now we are asked to find how much it can hold. So if any object how much it can hold. If I ask you, that means it talks about the volume, right? Whatever is the space inside that particular object is what is how much it can hold. So that is nothing but volume. So here we use volume. Okay, number of cement bags required to plaster it. Like if you want to plaster it, or let us say you want to paint a wall, whitewash the walls and the roof and everything. Okay, you want to clean everything. So in that case, you will be using the area of the walls and the roof and the floor, right? Not the space in between them, not how much space is there in that room. It's only the walls area. So here we will use the total surface area. I'll just write TSA for total surface area. Okay, so they simply write surface area also. They avoid using total. Okay, but then we can use TSA also. Alright, now coming to the next one. To find the number of smaller tanks that can be filled with water from it. Now if I ask you, how many small tanks can be filled with this much of water? Like so much of water is there in this particular syntax tank, right? It's a big syntax tank. Now from here, how many small tanks can be filled? Let's say you're filling small tanks. So how many such tanks can be filled? So what will you do? You find the volume of this, you find the volume of these tiny tanks and divide both of them. So that will give you the number of tanks which can be filled. Okay, so here also we use the volume formula. Okay, now coming to the next question. So the next question says, diameter of cylinder A is 7 centimeter and the height is 14 centimeter. Diameter of cylinder B is 14 centimeter and height is 7 centimeter. So it is given in the figure, right? Sometimes they may not give you the figure, you will have to draw the figure. So based on what you are reading, read it carefully and draw the figure. Okay, but here in this question it has become really easy for you because the ready-made figure is given to you. Now without doing any calculation, can you suggest whose volume is greater? Now just by looking without calculating, you should not calculate and find the answer, okay? But you should just say which is greater and verify it by finding the volume of both the cylinders. Then we should find the volume also, okay? Similarly, check whether the cylinder is with greater volume also has greater surface area. So first let's answer the question for the first one. So here, without doing any calculation, can you suggest whose volume is greater? So for this, let's answer. Okay, so we know they are asking about the volume, so let's write the volume formula. V equals to pi r square h. It's a cylinder, we have to write this formula. Now volume of tank A and tank B I have written separately, right? Now for tank A, it's going to be, for pi I can put 22 by 7. R is going to be half of 7, right? 7 is the diameter. I have to use the radius, that is half of 7. So 3.5 into 3.5. Why 2 times? Because it's r square. R has to be multiplied 2 times. And h is 14, so I put 14. Now see, I can cancel. 7 2s are 14, right? So now I get 22 into 3.5 into, now 3.5 into 2 is 7 again, right? Double of 3.5 is 7. So I am getting 22 into 3.5 into 7. Now I am not calculating it, I am just keeping it as it is. Now for B, tank B, if I come, I get V equals to 22 by 7. So half of 14 is, radius is 7 itself. Here it's 3.5, right? And from here it is 7, right? So now 7 into 7 into height is also 7. So 7. So one of the 7 gets cancelled. And you are getting 22 into 7 into 7. Now you compare these two. Here you have got 122. Here also you have got 122. Here you have got 3.5. But here you have got a larger number, 7. Here also 7 and 7. So here you are actually getting a larger number. So this has to be greater, right? So without calculating, I can say that volume of B is greater because it has got a larger number being multiplied. Okay. Now they are asking you. Now coming to the second question here. Verify it by finding the volume of both the cylinders. So now we need to find the volume of both the cylinders. So now you people calculate it, multiply and see what you get here and what you get here. Okay. And check if this is greater than this. Alright. Okay. Now we will come to the next question. Check whether the cylinder with greater volume also has greater surface area. So now we already found that B has got greater volume. We need to find if B has greater surface area also. Okay. So we write the total surface area formula. 2 pi r h plus r. Okay. So A and B again I have written separately. So total surface area of A is going to be 2 into 22 by 7. So 2 into 2 pi. For pi I have written 22 by 7. Into r is 3.5 for A. And h is 14 plus 3.5. So here you get 2 into 22 into, see now I can cancel this. 7 5s are 35, right? Now if it is 3.5, I can put a point here. So I get 0.5. Okay. So 2 into 22 into 0.5 into 14 plus 3.5 is 17.5. So I get 2 into 0.5 is 1. See, if you have half, 0.5 is nothing but half, right? Half being multiplied 2 times, half into, like, one more half, if you add half plus half is going to give you 1, right? So that is what you are getting. 2 into 0.5 is 1. And you have 22 into 17.5. Okay. So 1 into 22 is 22 into 17.5. And here you see, you have got that, come to B. Okay. 2 into 22 by 7 into R is also 7. Height is also 7 and R is also 7. So you get, see the 27 and 7 get cancelled, and you get 2 into 22 into 14. Okay, 7 plus 7 is 14. So 22 into 2 is 44, 44 into 14. Now you see, this is 44 into 14, this is half of 44. 22 into, just the 17.5 is slightly more, that's it, isn't it? It's not much more, it's just slightly more. So obviously, this seems to have a larger total surface area. Okay, but still, you have to multiply and then check if this is correct. Okay, so we can conclude that volume of cylinder B is greater than volume of cylinder A, and same way, surface area of cylinder B is also greater than surface area of cylinder B. Okay. Alright, now come to the next question. Find the height of a cuboid whose base area is 180 centimeter square and volume is 900 centimeter cube. So there is a cuboid. So let's draw a cuboid. Okay. Okay. So now the base area. So area of the base. Area of the base is this one, right? This is what is your area of a base. Let me just shade the area of the base. This is the area of the base. And they have given area of base is 180. So that we have written this 180. Okay. And then next they have given, see, this is actually area is length into breadth. So your length into breadth is 180. Okay. Now they have given volume is 900. So we know that volume is length into breadth into height. We'll put height also here. And that is 900. So length into breadth is 180. We have found out, right? So this length into breadth, we can use it for here. This length into breadth. Okay, I can write 180 for this length into breadth. And height I will write as it is equals to 900. Okay. Now height is equals to 180 goes down because it's multiplied. When it goes to the other side, it goes as a denominator. So it gets divided. So 900 over 180. Now you see, you can calculate it. 0, 0 gets cancelled. 9 2s are 18. 9 10s are 90. 2 5s are. So height is 5 centimeter. Understood? That's it. So now come to the next question. It says a cuboid is of dimension 60 centimeter into 54 centimeter into 30 centimeter. So when they give you something like this, it is understood that it's like, length, breadth and height. Okay. So they will not mention it if this is length, this is breadth, this is height. So we can take anything actually. Anyways, to find the volume, you just have to multiply all these three. So anything could be taken as your length, breadth or height. Okay. So here now, usually when they write something like this, the first one goes for the length, the second one goes for the breadth and the third one goes for the height. Now they are asking you how many small cubes which size 6 centimeter can be placed in the given cuboid. So there is one big cuboid. Let's say this is the big cuboid. Okay. And this is 60 and 54 and 30 is the height. Okay. Now there are certain small cuboids. Let's say these are the small cuboids. Okay, 6, 6 and 6. This cuboid will have all, small cube. Cube has all three sides equal. So now how many such small cubes can be put into this bigger cuboid? They are asking you. So you just have to divide the bigger cuboid by the small cube's volume. Okay. Now volume of cuboid is 60 into 54 into 30. Now don't multiply it. Let's keep it as it is. Okay. Later on when we are after calculating, after solving it, after dividing it, we will see what all is left out and then we will multiply it. Okay. So don't go for multiplication in the middle of the question. Now volume of cube is 6 into 6 into 6. So this also I am not multiplying. I am just keeping it as it is. Okay. Now I know that number of cubes that can be placed will be volume of cuboid. So this I have to do volume of cuboid divided by volume of cube. Okay. So volume of cuboid is 60 into 54 into 30 divided by 6 into 6 into 6. Now since it's all multiplication, so note this properly. It has to be multiplication. Only then I can do with this kind of a calculation what I'm going to show you. Okay. If it had a plus or minus, I can't do. Whatever I'm going to do now, I can't do if there was a positive or a negative sign, if it was having a plus or a minus sign. Okay. Only if it is having a multiplication sign, I can simplify it. So I can do this. See, 6 tens are 60. 6 nines are 54, 6 fives are 30. Okay, so I'm left out with 10 into 9 into 5. So which is equals to 9 fives are 45. 45 into 10 is 450. So 450 cubes could be placed. Okay, so now 1 to 4 question. I hope you people have understood. So memorize the formulas, all the 3 formulas which I have given here. All these 3 formulas you should by heart it. Okay, and these 4 problems you write it in your classwork. Okay, I will see you with the next video, which consists of the remaining questions in this exercise. Allah Hafiz. Thank you.